Hi everyone. So today's lesson we will actually find the terms of a geometric sequence. So if a geometric sequence is given and if we have to find the 100th term or the 300th term, it is not possible to multiply the common ratio each time. So we use a simple formula in order to generate any term of a geometric sequence. So this formula is Tn is equal to ar to the power of n minus 1. So first step is to actually finding the proof of the formula. How do we get that formula? So let's take a simple example. Consider the finite geometric sequence of 7 terms. Okay. So here I'll just write down a sequence 3, 12, 48, 192 and 384. So which means when you multiply by 4 each time, you get the next term. So first term multiplied by 4, you get 18. Again, 12 times 4 gives you 48. 48 times 4 gives you 192. 192 times 4 gives you 384. So now let's actually write down. So the first term is equal to 3. So therefore, in general form, we normally denote the first term as A. Okay. So the second term, how do we get the second term? The second term is 12. So instead of writing it as 12, I'll just write it in terms of 3 and 4. So we have the common ratio is 4. So I'm just, in order to derive the formula, I'm just writing the second term as 3 times 4. So therefore, how do you write the second term as general form? You write it as 8 times r to the power of 1. Next, how do you write the third term? The third term is 48. So instead of writing it as 48, I'm just going to write it as 3 times 4 times 4. So 3 times 4 times 4, which means you can write it in general form as 8 times of 4 times 4. 4 is the common ratio, so we can write this as r to the power of 2 or r squared. Next, how do we write the fourth term? Fourth term, we can write it as 3 times 4 times 4 times 4. So which means T4 is equal to 8 times r cube. So therefore, when you look at the fourth term in general form, we have written T4 as 8 times of r cube. So the power of r is 1 less than the number of the term. So therefore, we can actually, when you write it in general form, Tn is equal to 8 times r to the power of n minus 1. So that's it. We have got the formulas. We don't have to write the multiplication sign in between. Just have to write this ar to the power of n minus 1. Okay. So what is Tn here? Tn is the nth term. A is the first term. And you have r is the common ratio. So r is the common ratio. So therefore, we can actually see that in this sequence, we can see r is equal to 4. So when we write in general form, we can actually see that Tn is equal to ar to the power of n minus 1. So Tn is referring to the nth term, A is the first term, r is the common ratio. So to find any particular term in a geometric sequence, we can just use the simple formula ar to the power of n minus 1. So next we will actually look at an example which is finding the 12th term. Find the 12th term of the geometric sequence. Okay, how do we find the 12th term? So look at this example 210, 50, 250, and 1250. So therefore, how do we find the 12th term? So in order to use the formula, first term is 2. So r is equal to 10 divided by 2. That gives you 5. So therefore, what is the formula used? Tn is equal to ar to the power of n minus 1. So therefore, we have a is 2 and r is 5. And n is referring to, so we're finding the 12th term. So you replace n as 12. So 5 to the power of 12 minus 1. So therefore, 2 times of 5 to the power of 11. So 5 to the power of 11. So that gives you, so first when you use your calculator, first you have to evaluate what is 5 to the power of 11. And then you times it by 2. Okay. So that will give you 97,656,250. Because it is a geometric sequence, you're multiplying by the common ratio, you get a very huge value. Okay, so the next is actually, let's do another example where we are actually finding when two terms are given, how do you find a particular term? So therefore, let's look at this example. The second term of a geometric sequence is 8. And the fifth is 512. Find the 10th term. So find the 10th term. So therefore, the second term of the sequence is 8 and the fifth term is 512. So in order to find the 10th term, we need to know the first term and the common ratio. So therefore, T2 is equal to 8 and we have T5 is equal to 512. So we have to use the general formula, or otherwise we call it as the explicit rule, which is Tn is equal to ar to the power of n minus 1. Using this formula, we have to form an equation. So when it is T2 is equal to, replace n as 2 in here. We don't know what is a and r, just write it as a and r to the power of 2 minus 1. So therefore we have T2 is equal to ar. So if it is to the power of 1, we don't have to write the power as 1. By default, we know that the power is 1. So T2 is 8. So replace, in the place of T2, we write it as 8. 8 is equal to AR. And next, we will actually again the second equation. So this is equation 1. So again, just like this equation, we will actually use the fifth term in terms of equation. So therefore, T5 is equal to, I'll just draw a line here. T5 is equal to AR to the power of 5 minus 1. So T5 is equal to AR to the power of 4. So we have the value for T5, which is 512. So we write 512 in the place of T5, which is equal to AR to the power of 4. That gives you the second equation. So we have two equations. So when it comes to geometric sequence, and if two terms are given, and using the two terms, when we have to find the first term and the common ratio, we always divide. We actually form an equation using the general formula, and then we divide the second equation by the first. So divide 2 by 1. Okay. So therefore, we have the second equation is AR to the power of 4 is equal to 512. And then you divide the second by 1. So the first equation is AR is equal to 8. Okay. So now when you divide AR to the power of 8 divided by A is 1, R to the power of 4, applying the index laws. R to the power of 4 divided by R gives you R cube, which is equal to 512 divided by 8 gives you 64. So therefore r cube is equal to 64. So r is equal to cube root of 64. What is cube root of 64? R is equal to 4. So the common ratio is 4 here. And in order to get the first term, which is a, you can just sub in any of the equation. Always the first equation is the easiest one. So we know that the first equation is AR is equal to 8, isn't it? So substitute R is equal to 4 in equation 1. So therefore we have what is equation 1, which is, let's look at the equation 1 here. AR is equal to 8. So we write AR is equal to 8 here. And therefore sub in the value of R is 4. 8 times 4 is equal to 8. So A is equal to 8. Divide that by 4. That gives you 2. So we have now got the value for first term, which is 2. And R is equal to 4. So now we can. So what is the question here? We haven't completed the question. Here the question is asking you to find the 10th term. So therefore we have to find the 10th term using this formula. Tn is equal to AR to the power of n minus 1. So T10 is equal to, sub in the value of AR and n here. A is 2, R is 4. So 2 times 4 to the power of 10 minus 1, which is equal to 2 times 4 to the power of 9. So always remember, when you use a calculator, first you find the value for 4 to the power of 9, then you multiply that by 2, and that gives you 524,288. Just use your calculator, and this gives you the 10th term. So let's actually do a quick review of this example. So the second term of a geometric sequence is given and the fifth term is given. Second term is 8, fifth term is 512. So when it comes to a geometric sequence, use the general formula to actually form two equations. So using the formula, Tn is equal to AR to the power of n minus 1. Sub in the value of n. So for you, when you have the second term, substitute the value of n as 2 and then replace the second term T2 as 8 because the second term here is 8. And then same way you have to actually frame an equation for the fifth term as well. And then you divide the second term by the first in order to get the value for r. So in this case, when you divide the second term by first, you get r cube is equal to 64. So you get r is equal to 4 and you substitute the value for r in any one of the equation to get the value for a. So in this case, we get a is equal to 2. And then the last part of the question says find the 10th term. So you can actually find any term using this general formula, which is Tn is equal to AR to the power of n minus 1. So therefore we get T10 is equal to 524,288.